How are you, my friends? This is Calculus 1 Solved Questions. This video is about curve sketching of rational functions. And this is part 1. And for sure, you can expect part 2 and maybe part 3 and part 4, as I think. Question number 1, sketch the graph of the rational function f of x is equal to x squared plus 1 divided by x squared minus 1. We will go in details for this. We will find now the first derivative f prime. So I can use the quotient rule. I wrote it here for you from lecture number 7. U prime v minus v prime u over v squared. The derivative of this x squared plus 1 all prime x squared minus 1 minus from the formula x squared minus 1 prime and then x squared plus 1 divided by all this, the denominator v squared. This is 2x. This is also 2x. So when you multiply here, you get 2x cubed minus 2x cubed minus 2x. So you will get f prime simple minus 4x divided by x squared minus 1 all squared. This is f prime. We need it in the graphing. Now let's find the second derivative. F double prime, we can use also the quotient rule, the derivative of minus 4x times x squared minus 1 squared minus, this is a prime here, if you can see on this bracket, x squared minus 1 squared, this is a prime, that's a derivative there, minus 4x. It will be this one minus 4, the derivative of minus 4x. This one we leave it. Here we have minus 2, bring it down, and then 2 minus 1 in the power, times the derivative of the inside is 2x times minus 4x. Now here we can take, see this is a minus 4, and there is a minus 2, and there is a 2 here. So we can take minus 4 as a common factor, also x squared minus 1 as a common factor. We have seen this idea before. Now inside the bracket, you will have x squared minus 1 minus 2 times 2x. So you can take, this is a 4, you can take it common factor or minus 4, or you can take this 2 and 2 when you multiply them. Anyway, inside you will have minus 4x squared. So minus 4 out, we can cancel one of these factors, x squared minus 1. Here we have x squared minus 1 minus 4x squared. So it will be, put the minus inside, because we will have here minus 1 and minus 3x squared. So leave the 4 outside, make it simple, neat, easy, and nice. 4, 3x squared plus 1 over x squared minus 1 all cubed. This is f double prime. Now let's study f prime using the table of signs. Now here we have the critical values at 0, where f prime is 0 or f prime is undefined. So we have 0, we have to study f prime at 0, minus 1, and 1. And then we put here all the factors, minus 4x. This one we have to factor it. It will be x minus 1 squared, x plus 1 squared. But on the table, it will be all plus. Why? Because we have a squared here. If we have a cube, or any odd power, then we have pluses and minuses. Now here, if we take a negative number between minus infinity and minus 1, this will be plus. And also this will be plus. After the 0, on the positive number, this will be minus and minus. So when you multiply all these and divide, you get plus, plus, minus, minus. So this is f prime. See, f prime positive, f is increasing. F prime positive, f is increasing. So we have increasing, increasing, then decreasing, decreasing. So at the 0 here, we have local maximum. Put 0 in the function here, you get minus 1. 0 minus 1 is the local maximum. F increases, where increases? From minus infinity to minus 1, union minus 1 to 0. Okay. Now, why we cannot make here minus infinity to 0? Maybe you can think to make minus infinity to 0 one interval. You cannot do that because at -1, the function is not defined. There is discontinuity at -1. So there are two pieces in the graph here. And the function increases from 0 to 1 union 1 to infinity. Now let's study here f double prime. Study concavity here, f double prime. So we have -1 and 1. See, from these, that will make f double prime undefined. But we have x minus 1 cubed, x plus 1 cubed. As I told you before, we cannot put all pluses here because this is an odd number. So if we take a negative number here, between minus infinity and -1, let's say -5. So -5 minus 1 all cubed will be negative, and this one will be negative. Between -1 and 1, I can take 0. This will be negative, this will be positive. After 1, it will be, both are positive. So when you divide here or multiply, it's the same. It will be f double prime positive. The function concaves up. Also here concaves up. If f prime is negative, the function concaves downward. So downward between -1 and 1, the function concaves up between minus infinity to -1 union 1 to infinity. Here we have no inflection points. F double prime cannot be 0 for any value of x. We have a change in the concavity, but these numbers should be in the domain. They are not in the domain of this function. See, the domain all real numbers except 1 and -1. They change concavity at these numbers, -1 and 1, but they are not inflection points. Let's find the vertical and horizontal. We have seen similar examples. We factor the denominator x minus 1, x plus 1. If we take the limit of the function as x goes to 1 from the right and left, or x goes to -1 from right and left, you will find the answer will be infinity. So we can conclude we have two vertical asymptotes, and the horizontal also is simple. Divide by x squared up and down, you will get 1. This one is the limit. Y equals 1 is the horizontal asymptote. Now let's put everything together for question number 1 on the graph. We have vertical asymptotes 2. So these are the red ones, you see. Horizontal asymptote y equals 1. This is the blue one. This is the function given, the black. We have to put the graph here. F prime is there. F double prime is there. Critical point 0 minus 1 local max. See, this is a local max. And this is the end of question number 1 after so many slides. F increases. See, F increases from minus infinity to -1. See, at -1, there is discontinuity here. Union -1 to 0, also the function increasing like this. The function is decreasing from 0 to 1, here this part, union 1 to infinity. Concaves up, concaves down, we have mentioned that. Let's see question number 2, please. Sketch the graph of this rational function f of x is equal x squared minus 1 divided by x squared plus 1. Do you see any similarity between this question number 2, question number 1? Or do you remember question number 1? The minus was in the denominator and the plus was in the numerator. Let me show you here. This is the idea of question number 2. Please note that question number 1 was to graph x squared plus 1 over x squared minus 1. We did everything possible there in the details, question number 1. Question number 2, this is what we need now. Look at question number 2 here. We need to graph x squared minus 1 over x squared plus 1. A little similar. So I suggest that you try it. Use similar steps to graph the function in question number 2. But there is a little change there. So I put the answer only the final answer in one slide. This is the answer of question number 2. The only thing here is a big difference. There is no vertical asymptotes. Why? Look at the denominator, x squared plus 1. There is no value for x, no value. That will make the denominator 0. So no vertical asymptotes. We have horizontal, yes, y equals 1. We can do that, divide by x squared everywhere. You can find f prime, critical points. There is a 0 and -1, local min. There are 2 inflection points, find f double prime. This is f double prime. When you check it, you find 2 inflection points, increasing, decreasing, concaves up, concaves down. This is the graph, very nice graph. These red dots are the inflection points. For more questions on graphing, you can check, please, lectures 18 and 20. And for more questions on Calculus 1 in general, you can see Calculus 1 solved questions. I would like to remind you that this video is curve sketching part 1. So please, you can expect or wait for part 2, part 3, part 4 minimum. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.